Hey everyone, this is Bhargav Sudhar, and today we will discuss about isomorphic graphs. So in this today's session we will discuss what is an isomorphic graph and how to check whether two graphs are isomorphic or not. Okay, so first let us understand what is isomorphism or what is isomorphic graph. Okay, so two graphs, this G1 and G2, are said to be isomorphic if there is a one-to-one correspondence between their vertices and between their edges such that this incidence are preserved. Okay, so what is this incidence? We will discuss later in the examples. Fine. So in other words, two graphs are isomorphic if this two or three conditions hold. So the first one, number of vertices has to be same. Fine. In two graphs, number of vertices has to be same in same manner. Number of edges also has to be same. Then third, see, if G1, the first graph, has n vertices of degree k, then this G2 must have exactly n vertices of degree k. Okay, and the last one, adjacency is preserved, or this incidences are preserved. So if all these conditions or all these axioms preserved, then we can say that these two graphs are isomorphic. So let us discuss some basic examples. So here we have one graph, that is A1, A2, A3, A4, four vertices are there, and how many edges are there? Total 6 edges are there. And the second graph, B1, B2, B3, B4. Okay, now as you can see that just by looking at this graph, is it an isomorphic graph? So no, some students can easily say that no, they are not isomorphic because their shapes are different and all stuff. Fine, but actually it is an isomorphic graph. Fine, so how? Let us discuss. Now here you can see that by just looking they are not isomorphic, because one is square and the another one is like pyramid or triangle. Fine, but it is an isomorphic graph. How? Now first check how many vertices are there. So total in first graph we have total 4 vertices. Okay, now in second graph how many vertices are there? So total 4 vertices are there. So the number of vertices are same. Now just calculate number of edges. So total how many edges in first graph? So we have 6 edges. Now in same manner in second graph we have 6 edges. So these two conditions hold. Now then here, now each and every vertex, it is of degree what? So here you can see that this A1 it is of degree 3, A2 is degree 3, A3 is of degree 3, A4 it is of degree 4. So that means this has to be there in the second graph. So you can see that this B1 it is of degree 3, B2 it is of degree 3, B3 it is of degree 3, and same manner B4 it is of degree 3. So that means up to this we can say that all these conditions are satisfied. Now this adjacency, so that means we need to have this adjacency. So for A1, what is the corresponding point or vertex? So let's take B1. Fine. So now A1 it is incident or it is related to A4. So that means A4 is B3. Now in same manner A4 A2. So that means B1 and B2. So A2 is B2, and last A1 A3. So that means this A3 it is B4. Now just imagine this B4. Okay, just fix B3, B1, B2 as it is, and B4. Now stretch this B4 up to this. So now you can imagine this just becomes square or rectangle like this. So that means it is an isomorphic graph. Now let us take another example. Just consider this Z and this consider N. Now see, this there are how many vertices? 1, 2, 3, 4. And in same manner, how many vertices? Total 4 vertices are there. Total how many edges are there in first? 3 edges. And here how many edges are there? So total 3 edges. Now we haven't given their names, their vertices names. Why? Because see, now if you rotate this N, now if you rotate this Z, fine. So if you rotate this Z like this, so that means I think 90 degree. Okay, so you will get N. So there is no need to check all those conditions. Fine, because by rotating or some shifting some of the vertices, you will get the same graph. So that means it is an isomorphic graph. So this Z and N, and again you can rotate this N to 90 degree. So that then you will get this Z. So it is obviously just by looking, it is an isomorphic graph. Now let us discuss another example. Now check whether the following graphs are isomorphic or not. So this is a good example. So this is the first graph, name it as G1, and this is second graph, name it as G2. Now as you can see that this both the graphs, just by looking at this graphs, you can say that it is an isomorphic graph, but it is not an isomorphic graph. How? See, just by looking at this, we have total how many vertices? Total I think 8 vertices. So in same manner 8 vertices, and you can see that there is only one change. This F1, it is shifted to this edge. Okay, so there is only slight change, but still it won't be an isomorphic graph. Let us see how. So these are the graphs. Okay, fine, in the question. Now see, this graphs G1 and G2 have same number of vertices. So that means the first step. So how many vertices are there? Total 8 vertices. So in G1 and G2, the number of vertices are same. In same manner, what about the number of edges? So graphs G1 and G2 have same number of edges. So how many edges are there? This 4 are outer and this 4 are inner vertex edges, and that means, and the rest 2, this 2. So that means 10. Now in same manner, this 4 outer edges, 4 inner edges, and 2 rest of edges. So that means total 10 edges are there. So the second condition also holds. So number of vertices and number of edges are same. So what is the catch? Now see, now 4 2-degree vertices and 4 3-degree vertices. Okay, so here you can see that the degree of D1 H1 G1 C1, it is 2, and degree of B1 and A1, it is 3, and degree of E1 F1, it is C. Degree of A1 is 3, degree of B1 is 3, degree of E1 F1, that is 3, and H1 G1. So we have 4 2-degree vertices. So what are they? D1 C1, H1 G1, and 4 3-degree vertices. And what are they? A1 B1, E1 F1. So that means this type of situation has to be there in the G2. So you just consider this. We have D2, H2, F2, and B2. They are of degree what? They are of degree 2. And in same manner here, A2, E2, G2, and C2, they are of degree 3. Okay, so that is also the correct one, or that is the same scenario, but still it is not an isomorphic. How? Why? Because adjacency is not preserved. So let us discuss about that. So here again the same graph. See, this is the important one. Now in graph G1, that means the left hand side, a vertex A1. So just consider this A1. Now A1, it is of degree what? So A1, it is of degree 3, fine, and it is adjacent to how many? This D1, E1, and B1. So it is adjacent to 1 2-degree, so that means this D1, and 2 3-degree vertices. Okay, so that means B1 and E1, because E1 and B1's degree is 3, fine. So just consider this. Again I am repeating, the vertex A1, it is of degree 3. So it is adjacent to 1 2-degree and 2 3-degree vertices. So that means D1, E1, and B1. Fine. So this type of scenario has to be there in the second graph. But in graph G2, no 3-degree vertex, it is adjacent to 1 2-degree and 2 3-degree. So as you can see that, just consider this A2. Now A2 is adjacent to E2, B2, and D2. So it is 2-degree. So it is 2-degree. But here we will have only 2-degree vertex. Fine. Only a vertex with 2-degree. But here it is of 2-degree, it is of 2-degree, and it is of 3-degree. Now consider this E2. Now E2 is adjacent to 3 vertex. So that is A2, F2, and H2. Now H2, F2, they are of degree 2. But this type of scenario is not there. Now just consider the 3-degree, that is G2. G2 is adjacent to C2, F2, and H2. So H2 and F2 also they have 2-degree, and C2 have 3-degree. So that is also not correct. Now same manner C2. C2 is adjacent to G2, D2, and B2. So same manner B2 and D2 have 2-degree, and G2 have 3-degree. But what we are looking for? We are looking for a 3-degree vertex which is adjacent to 3 vertices, in which 2 has to be of degree 3 and 1 has to be of degree 2. Fine, but that is not the case. So this type of scenario, it is not in G2. So that means adjacency is not preserved. Okay, and as this A2, E2, G2, C2, they are of degree 3, and each of them it is adjacent to 2-degree and 1 3-degree vertices. So hence adjacency is not preserved. So what does that means? These two graphs, they are not isomorphic, and this is the symbol. This G1, it is not isomorphic to G2. So this is the good example. Okay, thank you.